Video number 2, coming at you. An indoor physical fitness room consists of a rectangular region with a semicircle on each end. The perimeter of the room is to be a 200-meter running track. Find the dimensions that will make the area of the rectangular region as large as possible. So let's start with all of our given information. We have a rectangular region with a semicircle on each end. Makes sense, right? Looks like the inside of our field house. The perimeter of the room is to be a 200-meter running track. So that's going to be something that will help us. The perimeter is going to be equal to 200 meters. Find the dimensions. So we'll be looking for something times something that will make the area of the rectangular region as large as possible. So the area of the rectangular region, let's go ahead and give some labels. Remember, it doesn't matter what letters you choose. You just want to make sure you're consistent in how you label your picture. So I'm going to call this X, and then I'm going to call this, I'll just call this one Y. All right, so my area is X times Y. This is going to be my primary equation. This is the thing that I want to maximize, so this will be the one that gets calculus. Okay. So let's think then about what we know. We know the perimeter is supposed to be 200. So 200 is going to equal X plus X. But then I somehow need to figure out the area, the perimeter of those circles. Well, the perimeter of a circle is the same thing as the circumference. The circumference is equal to 2 pi r. So I could cut y in half, or remember 2 pi r, well, the circumference then in this case is the same thing as pi times the diameter. So I have a half of a circle and another half of a circle, which puts me together for one circle, which would be, I said y there, that should be x. That's going to be equal to pi times y. So 200 is equal to 2x plus one full circle, right? 2 half circles put together is one full circle. If you wanted to, you could change your variables, and you could, instead of calling this y, call this r and this r, and then use 2r. It's up to you, but I'm going with my variables that I have assigned. So next thing then, I want to use the helper equation to get things into one single variable. Well, I'm going to choose to make that single variable into, just debating, I think I'm going to make it into x's. So I'm going to solve this for x. So I'm going to have 200 minus pi y all over 2 is going to be equal to x. So when I go over here to my area equation, I get 200 minus pi y over 2. I'm going to put all this together into one term. So 200 over 2 is just 100, and I distribute in the y, minus pi over 2 y squared, right? So now I'm ready to do calculus because I have my primary equation in terms of one variable. A prime is going to be equal to 100 minus, the 2 is going to swing down, and I'm going to get pi y. So I have to consider where this derivative is equal to 0, and where this derivative may be undefined, but because we don't have a denominator at all, we don't have any undefined critical points, right? Add the pi over, so pi y equals 100, which means that y is equal to 100 over pi. Now, to test this, I could do a number line, or I could take the second derivative, a double prime. A double prime is just negative pi. Well, then a double prime, no matter what, even if I plug in that 100 over pi critical number, definitely comes back less than 0. which means that I have a graph that is concave down, and so I have, in fact, found a maximum. So there's a max when y is equal to 100 divided by pi. The question, though, asked for find the dimensions. So I know one of my dimensions will be 100 over pi, but I need to figure out 100 over pi times what? Well, to find my x value, I use that helper equation. So I have 100 minus pi over 2 times 100 over pi, because I'm subbing in for my y. That's going to be equal to my x value. So I end up with 100 minus 50, which will end up being 50 for x. So 100 over pi by 50 meters. All right, so that one again, you might have different variables than I do when you went through to check it, but our final answer should be the exact same. So if you paused your video to try the problem on your own and then just looked for the final answer, if you came up with this for your dimensions and you used totally different variables than I did, perfectly okay. We just want to make sure we get to the same final answer.